Acceleration is defined as the rate of the change of velocity with respect to time. Since we know what the acceleration represents, we can use this to derive the equation for acceleration to be acceleration equals change in velocity over change in time. Acceleration is a vector quantity, and we know this because velocity is also a vector quantity, and we are taking the change in velocity. Therefore, acceleration is a vector quantity. We can also find the units for acceleration from the equation. Since velocity is meters per second and the units for time is seconds, meters per second over seconds equals meters per second squared, which is the units for acceleration. Since acceleration is the change in velocity over time, we can find the acceleration by looking at a velocity versus time graph. The acceleration will be the slope of a velocity versus time graph at any point. So for example, in this graph, since it is linear, there will be a constant acceleration. We can find the acceleration for this graph by taking the slope. So it'd be the final velocity minus the initial velocity, which is 20 minus 0, over time, which would be 5. This comes out to be 4 meters a second squared. So the acceleration of this graph would be 4 meters a second squared. However, when velocity is constant, the acceleration will be 0 because the change in velocity is 0. This is illustrated in this graph because it is a constant 8 meters a second squared, so the slope is 0, therefore the acceleration will also be 0. Now we are going to show you some common equations that include acceleration that come up often in physics. First of all, we have final velocity equals initial velocity plus acceleration times time. Then we have distance equals initial velocity times time plus 1/2 acceleration times time. And lastly, we have final velocity squared equals initial velocity squared plus 2 times acceleration times distance.
Another very important aspect of acceleration is acceleration due to gravity. Acceleration due to gravity will always be negative 9.8 meters per second squared while you are on Earth. This is a constant because on Earth, the gravitational force that the Earth has on all objects depending on their mass will always be negative 9.8 meters per second squared towards the center of the Earth. Lastly, the other type of acceleration that is different is an acceleration on an inclined plane. This is different because this is where a mass is on an inclined plane and the acceleration is expected due to the incline. To accommodate for the incline, the only thing that changes is the force of gravity because force of gravity always points towards the center of the Earth. To accommodate for this, you must split up the force of gravity into an x and a y component. The x component of it is the force of gravity parallel. The force of gravity parallel is equal to the cos of theta, but only represents the x-axis portion. The y portion of the gravity that is split up due to the angle is the force of gravity parallel. The force of gravity parallel is equal to the sine of theta, so you are only left with the vertical component of the angle due to the inclined plane. After this, you can find the acceleration on the inclined plane due to the sum of forces, which will be the mass times acceleration is equal to the sum of forces in the x direction, and then you can also have the sum of forces in the y direction, which will be equal to mass times acceleration is equal to the sum of forces in the y direction. In this problem, we have Jesse Owens in the 1936 Olympics running the 100-meter dash in a time of 10.3 seconds, a new world record. Find the acceleration of Jesse Owens as he runs his event. Knowing what was given to us in the problem, we can start to set up the equation to find the acceleration by having the initial velocity equal to 0 meters per second, the displacement equals to 100 meters, and the time equal to 10.3 seconds as we saw for the acceleration. The equation that we would use is displacement is equal to initial velocity times time plus 1/2 acceleration times time squared. Knowing that equation, we can start to fill in the variables. D will be equal to 100, the initial velocity will be equal to 0 meters per second, The time will obviously be equal to 10.3 seconds, and then we will have the rest of the equation to be 1 plus 1/2 acceleration times time, which is equal to 10.3 seconds squared. Now we can begin to simplify. We will have 100 meters will be equal to 1/2 times acceleration times 106.09 when you square the 10.3 squared. Since the initial velocity is 0, when you multiply initial velocity times time, that number is canceled out and is no longer meaningful. After that, we can start off by dividing 100 by 1/2 to be equal to 200 is equal to acceleration times 106.09 seconds squared. And finally, we can divide 200 by 106.09 to get the acceleration to be equal to 1.88 meters per second squared is the acceleration of Jesse Owens in his world record-setting 100-meter dash. In this problem, we have the annual Cooper's Hill cheese roll in England, where the mass of the cheese is roughly 4 kilograms, as participants run down a 183-meter long hill at an angle of 40 degrees. Find the acceleration of the cheese as it rolls down the hill, as friction is negligible for this problem. To find the acceleration of the cheese, we can start off by labeling what was given to us. We know that the angle of the hill is at 40 degrees and that the mass of the cheese is 4 kilograms. The next step for solving the equation is drawing a free body diagram. We can start off by drawing an arrow perpendicular to the slope of the triangle pointing up, which will be the normal force. Another arrow pointing directly downward, which will be force of gravity. Another arrow that is pointing towards the bottom of the triangle, which is perpendicular to the slope, which will be the perpendicular force of gravity, and another arrow in the opposite direction of the normal force, which will be the parallel force of gravity. The final part for solving for the acceleration is setting up the sum of forces equation. In this instance, the sum of the forces equation will be the sum of the forces is equal to mass times acceleration is equal to only the force of gravity perpendicular to the slope, because there is no friction acting upon the block of cheese. So simplified, and we have the equation to be mass times acceleration is equal to mass times gravity times cos of theta. Since there is mass on both sides of the equation, we can cancel those out since they are not as important as the rest of the equation. So after that, we can simplify the equation to be equal to acceleration is equal to 9.8 times the cosine of theta, which is 40 degrees. Simplified, and the acceleration is found to be 6.3 meters per second squared. So the acceleration of the cheese as it's rolling down the hill is 6.3 meters per second squared.